set of instructions to this. Let's say write your answer with only positive exponents. Write your answer in the end with just positive exponents. You might have some negative exponents somewhere in the middle there, but finish with only positive exponents. If anybody's having a hard time getting started, let's remind ourselves, if you are dividing bases, what do you do with your exponents? Subtract. So keep that in mind as you work through a couple of these here. Let's start, if you don't mind, can we start on the right side of this fraction? Start with the ends. So what I've got here is I've got n to the 9 over n to the 4. So I'll repeat it again. I think it's worth repeating. If you were dividing like bases, you subtract your exponents. And then you write the answer to that in the top. So 9 minus 4 we all know is 5. And so as I get started here, I think I would write a fraction bar and then n to the 5th. 9 minus 4, of course, being 5. I'll write that in the top. Does that make sense? I hope it does. The next thing I'd tackle as I move from right to left here would be my m's. My m's are m to the 3rd over m to the 5. And so whenever you're dividing like bases, you subtract your exponents and you write the answer in the top. So this one's a little bit different. 3 minus 5, negative 2, right? So I would write m to the negative 2 up there in the top. And finally we arrive at the 9 and the 36. And in the past, the 9 over 36 would have been the easiest thing for you. But now that we start talking about exponents, now it all of a sudden feels like the most difficult thing. Let's remind ourselves of something very important. The 9 and the 36 are not exponents. They are bases. So you just reduce the fraction, right? What goes into both 9 and 36? 9 goes into both, resulting in 1/4. Right? So you divide 9 by 9 and you get 1. You divide 36 by 9 and you get 4.
Why don't you just... Oh, never mind. I see. It's the same.
Then you have to move.
And then to write it with positive exponents, you're right. We need to move that m base down. So your final answer would be n to the 5th over 4m squared. Wow. N to the 5th over 4m squared.
Wait, could we just divide 9 by 36?
And get 0.25? So a word, just like a word of advice on that one, that's numerically correct. And I would give that to you, depending on where you write the 0.25. If you write the 0.25 in the top, that's correct. If you were to write it in the bottom, that's wrong. But you'll find other teachers, probably for sure a college professor is going to balk at that. They're not going to like that. Because to write a decimal in a fraction is typically frowned upon. And so it would be better just to reduce the fraction, just for consistency's sake. Yeah. Go ahead, Matt.
Well, what I did was so I did the 9 out of the m to the 3, and then I subtracted that, and so then the m went away. Would that work? So I didn't get a negative.
What do you mean the m went away?
It left. Because m to the 3rd, but then you subtracted the m to the 5th, and so then the m to the 3rd goes away because it subtracted it. Right?
So did your answer have any m's in it?
Yeah, on the bottom.
M squared?
Yeah.
What are we talking about then?
Well, because I didn't get a negative.
You subtracted the other.
I'm okay. I'm okay if you kind of combine those steps. That's okay.
You subtracted the 3 from
Yeah, I get it. I get it. I'm not sure I want to broadcast that loud. I think, see, that's what I want to avoid. So, Matt, I think your way is okay. That's what I want to avoid. Okay. Any other follow-up questions? Okay, fantastic. Let's go ahead and move on to our next example. We did a monomial divided by a monomial, and so now we're going to talk about a polynomial, so more than one term, divided by a monomial. All right, so a polynomial divided by a monomial. And to help us understand how to do this, I want to remind you guys of how we add fractions. What do you have to add fractions? No.
Common denominator.
Common denominator. So if you have a common denominator amongst a couple of fractions, then it could look like this right here, right? A over D plus B over D, correct? Please pay attention all the time, okay? Seriously, I want you guys to get this. So if you have A over D plus B over D and you try to combine those fractions by addition, what does that look like in the end?
A A plus B over D.
Okay, so a plus b over d would result from that. What we are going to do is when we have a polynomial divided by a monomial, we are going to take that process that you guys just did very well, and we're going to reverse it. Okay, we're going to break them back apart. Break them back apart and then work with each fraction individually. So, for an example right here, it says divide 9x squared plus 3x all over 3x. So that's a binomial divided by a monomial, right?
Right.
So this is the situation we're talking about. Whenever you're dividing by a monomial, what we will do is we will split that fraction back apart. We'll reverse that whole thing we did up there. Here's what it should look like. It would be 9x squared over 3x plus 3x over 3x, right? Split apart the common denominator and add thing. And now essentially, haven't I created a monomial divided by a monomial plus a monomial divided by a monomial?
Yes.
That we just did. Joel, question.
Then do we, like, cross it?
And now we'll do some simplifying. Yep, now we'll do some simplifying. Yep, Brian, go ahead.
So for the 3x over 3x, can we just put 1?
Yes. Yeah, we just haven't simplified yet, but we'll get there. We'll get there. Okay, so let's simplify each term. Let's start off with the one on the left here. The 9 and the 3 are bases, aren't they? So we don't subtract them, we just reduce them. Or divide. In this case, what's 9 divided by 3? 3, okay. And then, whoops. And then how do I handle the x squared over x?
Subtract.
Subtract your exponents. So it ends up just being x to the first, or you could just write x if you want. And then I think the easiest way to look at the last one is exactly what I think Brian mentioned is, if you have something divided by itself, what should you get? 1. Something divided by itself is 1. Ben, your question.
On a quizzard test, do we have to split them apart?
No, there are other ways to do this. I like this way, but there are certainly. No. Let's not do that. Okay. If you want to talk to me individually about that, I don't want to confuse folks and get a hybrid of techniques. Okay. I'm sorry to cut you off, but I feel like when we get like 3 or 4 techniques, people get lost. There are definitely other ways to think about this. Definitely. Okay. So 3x plus 1 would be your final simplification here. And we'd be done. There's no like terms to be added, and that's kind of it. So our final topic of the day is dividing a polynomial by a polynomial. So let's look at that. Remind you of something from your past. The technique that we're going to be using here this morning is long division. Could you use hand this, please? Thank you. Long division. You guys remember this from like 6th grade or something like that? I want to remind you of this. So I'm going to write something on here and then I'll erase it. So if you're going to write this down, don't write it here because we're going to just use this, just as sort of a little momentum builder. So check this out. Do you guys remember doing problems like this? 12 divided into 178.
Yes. Yeah.
Remember doing problems like that? So what we did with this is we said the divisor out there, the 12, has a ones place and a tens place. Please pay attention. You're going to want to see this because we're going to use this on our problem here in a second. So you got 2 digits for a divisor. So we will take that 12 and we will divide it into 17, right? We ask ourselves, how many times does 12 go into 17? Or you could say 17 divided by 12 is how much?
1.
It's 1 plus a little bit more, right? So what we would do then is put a 1 right here in our answer, our quotient.
Got 5 left over.
And then you would go 1 times 12, right?
Yep, 12.
Which is 12.
17.
And then what do you do with 17 and the 12?
Subtract. That means 12 goes into 58.
Hold on. You're getting a little too far ahead of me. Some of you guys are really good at this. Don't you bring the 8 down now?
Yeah.
So you bring the 8 down. 58. 12 goes into 58 4 times. That's right. 4 times 12? 48. Subtract and you get 10. So some of you maybe were used to putting R10. We're not going to do that.
12 over 10.
10 over 12. You write the remainder as a fraction over your divisor. So if you can remember how to do that, and listening to you guys talk, a lot of you do remember how to do that. That's pretty good. We're going to be doing a similar process with our polynomials. Okay? It's obviously more complicated, but it's a similar process. So here we go. This is going to require your full attention. And what we will do tomorrow, my plans for tomorrow are to practice numbers 3 and 4 is similar to it, to practice these repeatedly tomorrow. You're going to need a lot of practice with these, and you'll have the weekend to of course, to continue to practice. So here's how this goes. We're going to take 3x minus 2, and we're going to divide it into this trinomial, 9x squared plus 9x plus 7. And just like with regular old long division that you guys learned in 6th grade, we don't try to divide the whole dividend by the whole divisor in one shot. We simply take basically a little part of the divisor and divide it into a little part of the dividend, and then proceed, and then do it again, and then do it again, right? You repeat a process several times to get to an answer. So here's how this works here. We are always going to be focused on getting rid of the lead term, or the lead degree. So here's how we do that. We're going to go 9x squared divided by 3x. Okay, we're just going to be concerned about the lead degrees, and we'll peel them away one by one, and eventually we'll be done with them, and we'll be done. So what do you guys think? 9x squared divided by 3x, if you wanted to write it off to the side, you could. You could say 9x squared divided by 3x. What do you think that is?
3x.
It's 3x. Good. So this is 3x. And so what we do is we write that in our quotient line up here. That's the first part of our answer. So this is kind of like what we just did with long division, right?
Yeah.
Once you wrote the first part of your answer in long division, what did you do with that with the divisor? Didn't we multiply?
Yeah,
Multiply?
you did.
Yeah, first part of your answer, and then don't you multiply times the divisor?
Yeah.
So check this out. I'm going to multiply 3x times my divisor out here. But in order to do that, I really have to use the distributive property.
Oh.
So what would that be if we distributed?
9x squared
Minus 6x. Now what comes next? Which step?
the next leading term.
Before this. Subtract. Don't we have to subtract? Now, I will say that the subtraction step is the one that trips people up the most. So here's what I suggest you do. Put that 9x squared minus 6x in parentheses. Put a little minus sign outside because we're going to be subtracting everything in there, not just the lead term. So I'm going to use a little highlight here to emphasize what I'm doing. So I'm going to use an orange highlighter here. Here's what I'm thinking. 9x squared minus 9x squared. What's the result?
0.
0. If you subtract something from itself, you should get 0. Now, if that number right there is not 0, then some sort of mistake has been made. So you want that lead term to subtract out to be 0. But if I look at this other subtraction, it probably won't do that. So this will be in blue. I'm going to go, this is the one that people will often make a mistake with, so pay close attention. 9x minus negative 6x.
15x.
15, it's really plus a positive, right? Good. So 15x is the result of that. Nice job. And now we bring the 7 down. Now we bring the 7 down. So plus 7. So we just did one whole cycle. We're going to do one more cycle and then we'll be done. So just like we did 9x squared divided by 3x, now we're going to do 15x squared divided by 3x. Or 15x, sorry. 15x divided by 3x. So what is 15x divided by 3x? Not quite. Wouldn't the x's subtract out or cancel out there? So you would just get 5. So plus 5 goes right there. And then what did we do with the 3x and the divisor? We multiplied, distributed. So what do we think we do with the 5 in the divisor? Same thing. Same thing. So we're going to multiply by the distributive property. So 5 times this, 5 times that. So we end up with 15x minus 10. And then it's subtraction again. So parentheses, subtract. Let's remember how this goes again. In purple, 15x minus 15x.
Done.
0. If that's not 0, we got a problem. So we're in good shape because that's a 0. And then in brown, 7 minus negative 10 is really
17.
17.
So it's 3x plus 5 plus 7, so 3x plus 12.
No. So 17 is the remainder, right? That's exactly what we do. We put the remainder over the divisor, so it'd be 17 over 3x minus 2. So our whole answer, boxed up here on the top, is that
Why
expression
is
right
it over
there.
3x minus 2?
You always put it over the divisor.
Cause you can't divide it
Oh.
out like this.
Yeah, you can't divide it any further. So, go ahead, Joel, question.
How come we don't divide the negative two also? Like, it's just the 3.
Well, we use the negative 2 every time we multiplied, right?
Yeah.
But what we're trying to do is we can't just do this in one step, right? So our strategy is to reduce the degree each time. Notice that in this, like in the dividend, the degree was 2, right?
Yeah.
And then in the next step, we got rid of the second degree and we were down to first degree, right? And then we got rid of the first degree and then we're down to the 0th degree. So we're just trying to reduce the degree one by one. The way we do that is to divide by 3x. Now the negative 2 gets factored in, right, when we multiply.
Yeah.
Right? If negative 2 is something else, then this answer would be very different. It's not like we ignored the negative 2. It's just that every time we divided, we only considered, all right, what do we need to do to get rid of the lead term?
So if the negative 2 had an x on it, would we divide that?
Well, if it was 3x minus 2x, we would just combine those like terms and divide by x. Right? That make sense? A couple of other things I want you guys to notice real quick. Did you guys notice that our original dividend was in nice, beautiful, descending order? This is worth your time.
Yeah.
Nice, beautiful, descending order. Look at your answer. It's in descending order. The exponents go 1, 0, and technically negative 1. So if your quotient, if your answer does not go in descending order, we got a problem, right? If your degrees go 1, 1, something, it should go 1, 0, negative 1, or 3, 2, 1, 0, negative 1, or something like that.
Why is it over 3x minus 2 again?
Because we always write the remainder over the divisor.
And that was the remainder?
17 right down here.
Because 3x can't go into it.
You can't divide into that anymore.
Oh! Alright, thank you.
Yeah.
Wow.
I have a question.
Okay, yeah, go ahead.
So for like, so when we put the numbers at the top, like when we're trying to get rid of the first one,
Yep.
can it ever be like x squared?
It could, yeah. So if your original dividend, so the number inside the little division house was like 5x cubed, blah, blah, blah. So if it was like a third degree polynomial in there, then your first term in your answer would be something x squared.
And then, but
Yes.
what if the second term, so like for the second one, it's 3x cubed minus 4x?
So we lost a degree.
Yeah.
We'll talk about how to deal with that tomorrow.
Okay.
We got to put in a little placeholder.
Okay.
Wow.
Yep. Okay. Awesome job.